Hi guys, I hope you're liking, subscribing, commenting, sharing and referring these videos to your friends. In this video we are doing N factor for oxidizing agents. As we know, as oxidizing agents are responsible for taking any particular compound to its higher oxidation state. So they are just going to increase oxidation state of a given compound. That is a property of oxidizing agent. So we know that we have discussed in earlier videos that oxidizing agent itself will feel there is a loss in the oxidation state number of itself. So there will be a drop in oxidizing agents oxidation state, whereas the gain will be to compensate the compound's oxidation state. So we'll see first of all what are good oxidizing agents here. So the very famous is potassium permanganate KMnO4, potassium dichromate Ka2Cr2 okay, so these are, or similarly we can say SeO2 etc, CrO3. These are multiple oxidizing agent. As far as we talk about the concept, mole concept part, or we say volumetric analysis, these two are very important reagents and we need to learn in this video what about their N factor values. So as we know KMnO4, Mn is in +7 state. How do you know that? Oxygen is -2. Potassium being first member, it is +1. Please refer oxidation state video which has been already put on the channel. You will find all these details. So Mn is in +7 state. When it gets reduced to Mn +2, there is a drop of 5 which indicate N factor is 5, and this will happen in acidic conditions when we use this. If you use the basic medium for the same reaction, you will get in the same kind of reaction the drop will be just 1 and it becomes Mn +6. Okay, so KMnO4 will become K2MnO4 and this N factor will be written as 1. And if it is a neutral conditions, the same question, the drop which we get is drop of 3 and Mn +7 becomes Mn +4, and Mn +4 example could be MnO2. So if you see here, this is +4, this is -2, and the drop is 3, hence N factor is 3. So what is N factor or valency factor for KMnO4 in different cases? We'll simply say, we'll learn with a simple technique. It is BNA 135. Okay, so as we know in biology we discussed DNA. Now you remember BNA 135 is the code for KMnO4, and with this code we can solve any question without any problems. I hope this is very clear. So in basic medium the value will be 1, the neutral medium the value will be 3, in acidic medium the value will be 5. So let's say we got a question. Fe+2 is getting oxidized to Fe+3 and we have 2 moles of Fe+2. So how many moles of KMnO4 will be sufficient to oxidize it in, let's say, acidic medium? So they give the question KMnO4 in acidic medium. So we know N factor for this is 5. So my answers would be gram equivalents of two reacting things should be equal. So Fe+2 must be equated with the KMnO4 number. And as we know, Fe+2 you have taken 2 moles. So 2 moles into N factor of Fe+2 when it changes to 3 is increase of 1, which is N factor. So I'll say 2 into 1 is equal to, right hand side I don't know the number of moles of KMnO4. So what is N factor of KMnO4? It is 5. So can I solve this question mark? This question mark comes upon 2 by 5. So definitely you got the number of moles of KMnO4 with this logic. So we can solve such questions with very much ease. You're just equating gram equivalents of two reacting components. Okay, and then we are using the values which are known to us. Now let us see the another important thing, which is K2Cr2 in the discussion, potassium dichromate. Generally it will be given in acidic condition and it converts from K2Cr2 to Cr+3, and this takes a form of Cr2O3, which is in +3 state. This was in +6 state because these are +1 and -2. So the drop here is from 6 to 3. If you observe, the drop is 6 to 3. Can I say the drop is 3? But whenever this condition is given, you need to calculate the drop for both the chromiums. So for both the chromiums, the drop will be 3 into double, that is 6. Hence, the N factor for this question will be 6, not 3. So if the same question comes, okay, for Fe+2 question comes this time becoming Fe+3, and let's say this was 2 moles and this is to be solved, and they have given you K2Cr2 so what will be your answer? N factor is 1 for this, 2 into 1, moles are unknown, N factor is 6 for this, so what is question coming up? 2 by 6, that's 1 by 3. So we know that 1 by 3 moles of this particular thing is sufficient for the same kind of titration. Or if you come back here, you needed 2 by 5. So if they ask which is a better oxidizing agent out of these two, which is a better oxidizing agent for this reaction, so we can say 1 mole of this is giving you 6 gram equivalent, where the other one is giving you only 5 gram equivalents. Hence K2Cr2 is required in lesser amount. Hence, it is a better oxidizing agent. I hope you understood this video. Please like, subscribe, share. Thank you very much for your comments also. Thank you.